Hello friends. So we have returned back with a new video, and before going into the video, let me tell you that our videos are very bored. Before starting the video, let me tell you that our videos are really boring. But due to this, we have got one advantage that we are able to reach to the real client. So with this kind of talk, let us start our video. So have you ever wondered what actually happens when you press the send button on the WhatsApp? You type just one word, hello, you tap the green send button, and within a fraction of a second, the message appears on another person's phone, even if they are thousands of kilometers away. Sometimes it even appears on the laptop, tablet, and desktop simultaneously. But what actually happened behind the scene then? Did your phone connect directly to theirs? Did WhatsApp read your message? Where is your message stored? How does WhatsApp know where to send it? Why can your laptop still receive messages even when your phone is switched off? And perhaps the biggest question of all, why do old photos sometimes disappear while messages remain? Today we are going to answer all of these questions, and by the end of this series, you will understand WhatsApp at the level of a backend engineer. So let's begin with our today's video. So we have got the first one, the big picture. So most people think WhatsApp works like an email. They imagine that when you send a message, it gets stored forever on WhatsApp server. That is not how modern WhatsApp works. Instead, think of WhatsApp server primarily as secure delivery network. Your devices, not the server, are the long-term home of your chats. Let's start at the top. The first box is you. So, you type a message. The moment you press send button, the WhatsApp application starts a sequence of operations that all happen in milliseconds. Notice the next two boxes. The first is the local database and the second is the encryption engine. This is important, right? Your message is generally saved on your own device before it successfully delivered to anyone else. That's why if your internet connection suddenly disappears, you still see the message in your chat with a small clock icon. That message already exists locally in your device. It simply hasn't left your phone yet. Now look at the encryption engine. Before your message travels across the internet, it is encrypted. This means the readable text hello is transformed into encrypted data. Only the internet recipient's device can decrypt it. The server mainly sees encrypted data and routing information, not the readable message itself. Then, what happens when you press send button then? So let's zoom in. Imagine I type hello. The moment I press send button, WhatsApp does not immediately contact the internet. First, it creates something engineers call a message object. Think of a message object as a structured package containing everything needed to represent that message. It contains much more than the text itself. For example, a unique message identifier, the sender identifier, the recipient identifier, the time the message was created, the type of content, the delivery of state, encryption metadata. The text is just one field among many. Now WhatsApp generates a unique message ID. This ID allows every device involved to refer to exactly the same message. Even if millions of people send messages at the exact same second, each one receives a different identifier. Next, the app records the timestamp. This timestamp helps order conversation and support deliver acknowledgement. After that only, the message is returned to the local database. Only then does the encryption process begins. This is one of the biggest misconceptions about WhatsApp. Many people think all chats lives in the WhatsApp server, but in reality, your phone maintains its own local database. Inside the database are different kind of information. One table stores the message, another stores chat metadata, another keep track of delivery status, another store information about the groups. Media files themselves may be stored separately, while the database contains references to them. Because the information is stored locally, scrolling through years of chat history is fast. Your phone isn't asking the server for every message you scroll. Now comes one of the most important concepts, encryption. Suppose I send the word hello. If WhatsApp transmits that exact text across the internet, then anyone intercepting the traffic could read it. Instead, your phone encrypts the message. The readable text becomes encrypted ciphertext. It might look like random letters and numbers to whom it appear meaningless, but it isn't random. Be careful about that. It is the mathematical result of encryption using cryptographic keys. An important point is that WhatsApp end-to-end encryption means the company designed the system so that only the intended devices hold the key needed to decrypt the message content. The server help route encrypted packets, but they are not intended to have the keys needed to read your conversation. Notice something interesting. People often say, my message is encrypted. That is true, but there are actually multiple layers of protection over there. First, the message itself is end-to-end encrypted. Second, the network connection between your device and WhatsApp server is also protected using standard Internet Transport Security called as TLS. Imagine placing a locked safe inside an armored truck. The safe represents end-to-end encryption. The armored truck represents the secure internet connection. Even if someone could observe the network traffic, the net transport layer and encrypted message together provide strong protection. The encrypted package now reaches WhatsApp infrastructure. The first system it may encounter is a load balancer. A load balancer distributes incoming traffic across many backend servers. We have talked about this already in previous video also. Without this, one machine would quickly become overwhelmed because WhatsApp handles an enormous number of messages every day. After traffic is distributed, the server verifies that the connection is authenticated. Then, routing system determines whether the encrypted packets should go where. Notice that routing system is making decisions based on the metadata, such as recipient account and registered device, not by reading the plain text messages, and it is forwarded to next step. Now the server needs to answer an important question. Where should this message go? If every WhatsApp account can have multiple linked devices, the service maintains information about those linked devices and the public cryptographic materials needed for secure delivery. Suppose your account has one Android phone, one Windows laptop, one tablet. The routing system determines which system should receive the message. Each companion device is treated as its own trusted endpoints. But what if the recipient phone is switched off? Does the message disappear? No. The server temporarily stores the encrypted message in a queue. Think of it like a courier arriving at a house where nobody is home. The courier does not throw away the package. Instead, it waits for the recipient to become available within the service retention policies. When the recipient reconnects, the encrypted message is delivered. After successful delivery, the temporary queued copy is no longer needed and can be removed according to system design. So today we have followed the journey from the moment you press send until the encrypted messages return the WhatsApp routing infrastructure. Along the way, we discovered that your phone creates a structured message object. The message is saved locally before delivery. The content is encrypted on a device. A secure internet connection carries the encrypted packet. WhatsApp infrastructure routes encrypted data rather than the reading message content. Recipient devices are identified through linked device information. Offline recipients are handled using temporary server-side queues rather than permanent message storage. In the next episode, we'll continue the journey. We will see exactly how recipient phone decrypt the message, how acknowledgement create the gray and blue text, how multiple devices stay synchronized, and why media behaves differently from text. By the end of the next part, you will understand not only the message arrives, but how every stage of the delivery process works. So far, our encrypted message has successfully reached WhatsApp server. The server now knows who should receive it, but here's the interesting question. How does the encrypted message actually reach another person's phone? How does WhatsApp know whether the recipient has one device or five? Why do two gray ticks appear on your WhatsApp messages? And why can your laptop receive messages even your phone is switched off? And today we are going to answer all of these questions. When Your encrypted message reaches WhatsApp server. The server does not immediately send it to one phone. Instead, it first asks how many devices does it belong to. Every WhatsApp account has something similar to a device registry. Think of this as a secure directory. It does not store your chats. Instead, it stores information like which devices belong to your account, whether they are currently connected or not, their public encryption keys, their device identifiers. Imagine Bob wants an Android phone, a Windows laptop, an iPad. The routing system sees all those three devices. Now, another important decision happens. Which devices are online? Suppose the phone is online, the iPad is online, the Windows laptop is switched off. Immediately, the routing system prepares delivery only for the available devices, while queuing delivery for offline link devices according to WhatsApp synchronization design. This surprises many people. People often think WhatsApp sends one message to your account. Actually, from an engineering point of view, the service ensures that each link device receives what it needs to display the conversation securely. Think about your own device. Your phone has a copy, your laptop has a copy, your tablet has a copy. Each device maintains its own local chat database. This is exactly why turning off your phone no longer disconnects WhatsApp web or desktop. Every companion device behaves as an independent client. Now, let's follow one copy. The encrypted packet arrives on the recipient phone. Notice something important. The server does not decrypt the message. The phone performs the decryption. The encrypted data enter the WhatsApp application. The encryption engine runs. The appropriate cryptographic keys are used. Only then does the original message become readable again. The phone now sees hello, and at this point, the message is returned into the local database. Finally, the user interface refreshes. Only now do you actually see the message appear on the screen. That entire sequence from server delivery to appearing on the display typically happens in a fraction of a second under good network condition. Now let's solve one of the WhatsApp biggest mysteries. Where does the first gray tick come from? Many people believe it means the recipient received the message. This is not correct. The first gray tick simply means WhatsApp server has successfully accepted the message from a device. Think about sending a parcel. You hand it to a courier. The courier says, I have a package. That does not mean the recipient has received it. It only means the courier now has responsibility for delivery. Exactly the same thing happens here. Your phone uploads the encrypted packet. The server sends back an acknowledgement. Engineers call this as an ACK. When your phone receives the ACK, the UI changes from clock icon to one gray tick. The second gray tick represents another acknowledgement. This time, the recipient device says, I successfully received the encrypted message and stored it. Notice the wording. The recipient does not need to open the chat. The phone only needs to receive and process the message. Once stored successfully, the recipient device sends another encrypted acknowledgement back to the WhatsApp server. The server forwards that acknowledgement to the sender. Only then do you see those two gray ticks over there. Now comes the final acknowledgement, the blue tick. Many people think blue tick simply means the recipient opened WhatsApp. Actually, it's more specific. The read received is generated when the message is displayed in the conversation under a condition where read receipts are enabled and applicable. Once that happens, the recipient device sends another encrypted acknowledgement. The server forwards it, your phone receives it, the user interface updates, and the gray ticks become blue. This process is completely separate from message delivery part. Now imagine you are inside an airplane mode. You type, I am landing soon. You press send, nothing happens. Or does it? Actually, quite a lot happens over there. The message object is created, the timestamp is added, the message is stored locally, the encryption step is completed, only the upload cannot happen. So WhatsApp placed the message into its local outgoing queue. That is why you see a little clock icon in the WhatsApp message. The moment internet becomes available again, the app immediately uploads every pending encrypted message into the internet. And again, we'll see the gray tick over there. Now, years ago, you might have seen that WhatsApp desktop was dependent entirely on the phone. If the phone disconnected, the desktop disconnected too. Modern WhatsApp works differently. Every link device has its own secret identity. That means server can communicate directly with the laptop. Your phone does not have to relay every message anymore. Instead, server can send data to laptop, phone, or tablet. Each device independently decrypts and stores its own copy of data. This explains another mystery. Suppose your laptop receives a message. Where is it stored? On the laptop itself. Every link device maintains its own local database. That is why scrolling through conversation on a laptop feels instant. The app is reading data from local storage rather than downloading every message again from the server. Now imagine you are chatting on your phone. Suddenly you open your laptop. Within seconds, the latest messages appear. How? The laptop connects to the WhatsApp server. The service identifies which encrypted messages that device has not received yet. Those missing messages are securely synchronized to laptop. The laptop decrypts them locally. Its database is updated, the chat window refreshes. From a perspective, it feels like a magic. But from an engineer's perspective, it's simply state synchronization between the trusted devices. So today, we follow the second half of the message journey. We learned how WhatsApp identifies every link device, why messages are delivered independently to phone, tablet and laptop, how devices decrypt messages locally, what one gray tick actually means, what two gray ticks actually mean, how blue ticks are generated, why your phone can be switched off while a laptop continues working, how synchronization keeps every device up to date. In next episode, we will go even deeper, but for that one you have to comment down so that we'll upload the next step. We'll explore one of the most fascinating system inside WhatsApp called as media transfer. We'll answer questions like why images and videos are handled differently from text, why old media sometimes disappear, how large files are uploaded in encrypted form, what happens when you send a 2 GB video in WhatsApp, how thumbnails appear before the full image downloads, why downloading media is often delayed until you open the chat. By the end of next episode, you will understand the complete engineering pipeline behind WhatsApp media system. But for that one, you have to comment down below so that next video will be uploaded in this channel. We are not going to upload it until and unless a single comment will appear on this channel over this video.